Hello everyone, welcome back. Today we are continuing with demand, supply and price, but we are focusing more on the math side of this. So we're looking at linear equations for both demand curve and the supply curve. And when we say a linear equation, what we mean is that the slope is constant or the rate of change in y is always the same every time x increases by 1 unit. So a linear equation is essentially expressed in this format: y equals mx plus b or y equals b plus mx. Note, m over here will always reflect your slope and b will be your y-intercept. So this is also therefore referred to as the slope-intercept format. What is slope? It's the rate of change in y variable with respect to x, also referred to as rise over run. And intercept in this format, we're looking at the y-intercept. So for example, if x is equal to 0, what will happen to y? Y will be m times 0, which is 0, plus b. So y will be b. So this is your y-intercept that we are focusing on in this format. Y-intercept would be always b. What is the y-intercept? Equation or line intersects the y-axis. That's your y-intercept. So we can say the y-intercept coordinate point is 0, b. When x is equal to 0, the value of y variable will be b. Here I have an example, y equals 5x plus 10. So you can easily see that the y-intercept over here is 10. If you put the value of x equal to 0, this becomes 0. So y equals 0 plus 10 is 10. So b is your 10 or the y-intercept, and slope over here is 5. What's the slope? Remember, it's giving you the rate of change in y with respect to x. Every time x increases by 1 unit, this equation is telling you that y will increase by 5 units. The slope-intercept format allows us to draw these curves very quickly. Instead of solving for numbers, like in this case, I have the general form of the demand curve given as 10 minus 2p. One way is to solve for different coordinate points and then connect them together. So for example, what's the value of your quantity demanded when price equals 2? What's the value of your quantity demanded when price equals 3, and so on and so forth. So I've already solved these for you over here. These are pretty straightforward numbers. 2 times 2 is 4, so 10 minus 4 would be 6. So that gives you a coordinate point of 2 and 6. Then I have price equals 3. Quantity demanded comes out to 4. That gives you another coordinate point of 3, 4. And lastly, we have 5 and 0. So when price is equal to 5, this becomes 10 and we have 10 minus 10 is 0. So we can connect these dots on our two-dimensional space and get our general downward sloping demand curve. Note here, I have quantity demanded as a function of price. So if I'm following the mathematical format, I'll have quantity as my dependent variable on the y-axis and I have price on the x-axis. Now note that we did not use this method when we were drawing the demand supply diagrams. But before we go there, let's just simply draw this one. Here your intercept is 10 because if price is equal to 0, your quantity demanded will be 10. And conversely, if quantity demanded is 0, your maximum price available is 5. So these two intercepts, the y-intercept and x-intercept, we connect them together and we get our downward sloping linear demand curve. Here this is linear, so you can see this rate of change will always be 2. Rise over run will always be equaling 2 units. So every time price increases by 1 unit, quantity demanded is falling by 2 units. So that's your linear demand curve. But this is not how we drew our demand curves when we were looking at the analysis in chapter 3. In chapter 3, when we're drawing this, solved for price as a function of quantity demanded in order to express that relationship on a diagram. And that is what we call an inverse demand curve. It's simply now rearranging this relationship to represent it as price as a function of quantity demanded. So when I rearrange in a given equation in this format, we will refer to that as our inverse demand curve. And following the econ convention, we will not have quantity demanded, which is our dependent variable on the y-axis, but in fact, we should have price on the y-axis. So anytime you're given a general demand curve in this format, you must rearrange it and get the inverse demand curve. So let's work with an example and that will make it more clear. We have a linear relationship over here showing quantity demanded as a function of price. However, we have to rearrange it and solve for inverse demand curve in order for us to be able to draw it. So in order to find the inverse demand curve, I will take price on the left hand side. So in our case, I'll take 2p to the left hand side and my equation becomes 10 minus qd. All I'm doing is taking the p variable to the left hand side and qd to the right hand side. And now isolating p or getting rid of this 2, I have 5 minus half QD. So this is in our slope-intercept format again, but this is the inverse demand curve. Now you can see your y-intercept is 5 and your slope is negative half. And we can easily draw this equation on our two-dimensional space, but this time it will be the correct graphical representation for economics. So our inverse demand curve is showing us a vertical intercept of 5, and it is downward sloping with a slope of half, and that gives you your downward sloping demand curve in green. Similarly, we have the supply curve over here in general equation format, and again it's a linear equation. So quantity supplied is a function of price. Now the way we have expressed this equation over here, you can see A is your vertical intercept. So if price is equal to 0, quantity supplied will be equal to this number A. And the slope over here is B, which is giving you the rate of change in quantity supplied with respect to price. Every time price increases by a unit or a dollar, quantity supplied will increase by B units. So that's your slope of the curve if we were drawing it mathematically. And mathematical representation is always typically with quantity on the y-axis, which is your dependent variable, and it's a function of your independent variable, which is price. However, remember, as economists, we do the opposite. We like to put price on the y-axis and quantity on the x-axis. In order to do that, we again have to work with the inverse supply curve. So here is an example of the general format. Quantity supplied is a function of price, and this equation is given to you. However, note, this is not in the inverse format. This is perfectly fine explaining the relationship between the two variables theoretically, but just for the drawing part, we need to rearrange it and get our inverse supply curve. So in order to draw it, we cannot just simply put this on our diagram. It would be wrong. So make sure whenever you're given a general format for the supply curve or the demand curve, you have to rearrange it and get the inverse supply or the inverse demand. So let's solve for the inverse supply curve given our equation of QS equals P minus 4 over 2. So I want to rearrange this. In order to rearrange this, all I have to do is isolate P and take it to the left-hand side. Note, this is now again a positive relationship between price and quantity supplied. So the law of supply still holds, but now we'll be using this as our graphical representation. And this is our inverse supply curve. Now you can see my vertical intercept is 4. So that's our vertical intercept. It's upward sloping curve because our slope is positive 2. Now our axes are relabeled. Price is on the y-axis and quantity on the x-axis, following the econ convention. Vertical intercept is of 4 and we have an upward sloping curve. Let's now look at equilibrium. Equilibrium, remember, is simply when quantity demanded equals quantity supplied. So graphical representation would be where the demand supply curves are intersecting each other. Note, these are your inverse demand and inverse supply. So price is measured on the y-axis and quantity is on the x-axis. Now with given equations, we can actually solve for this equilibrium. In order to solve for equilibrium, all you have to do is remember that at equilibrium, quantity demanded equals quantity supplied. So you'll put these two equations equal to each other and solve for your equilibrium price first. And once you have your equilibrium price, you can substitute that into either of these and solve for your equilibrium quantity. And then we can also go ahead and draw these curves on a diagram and show our graphical representation of equilibrium in this particular market. So let's start with solving for equilibrium first. So I know at equilibrium QD equals QS. So we can put these two equations equal to each other. So this is 8 plus 1. I've taken this 1 and brought it over here. And this is P plus half P. So that's 9 equals 1 over 2P or 3 over 2P. P you can see is $6 per unit. So this is our equilibrium price in this case. Now how do I solve for quantity? I can substitute this price into either of these equations, either equation 1 or equation 2. So let's just substitute quickly into our quantity demanded. At equilibrium price of 6, quantity demanded would be 8 minus 6 is 2 units. Or you could have substituted this in your equation 2. At equilibrium price of 6, quantity supplied will also come out to be 2. Because remember, at equilibrium, both curves are intersecting at the exact same point. So quantity demanded is exactly equal to quantity supplied at the equilibrium price of $6 per unit. So that's our Q star. We can now draw it on our diagram. For graphing it, remember we have to solve for inverse demand and inverse supply. So let's start with the demand curve. Rearranging my equation 1 for the demand curve, solving for P, I have P equals 8 minus QD. So that's our inverse demand curve, reflecting a relationship between price and quantity demanded. But P is your Y variable now. And let's solve for my inverse supply curve. I have to rearrange this equation. So P is a function of QS. So I have half P equals QS plus 1. Get rid of the 2, so I multiply both sides of the equation by 2. I have P equals 2QS plus 2, or I like writing the vertical intercept first, so it is 2 plus 2QS. And these two are now your equation 3 and 4. So let's say this was 1, equation 2, equation 3, and 4. So 1 and 2 are your general demand and supply curve in their general relationship. And here we have the inverse demand and inverse supply curve, which we need to draw the diagram accurately. For your demand curve, the vertical intercept is 8 and it's a negative relationship. So I have my downward sloping demand curve, vertical intercept of 8. Every time quantity demanded increases by 1, price is decreasing by 1 unit. So that's your downward sloping demand curve. For supply curve, our vertical intercept is 2. Every time quantity supplied increases by 1 unit, price is increasing by 1 unit. Note, this is showing you that quantity supplied is your independent variable. When in theoretical fact, we know in theory, we know quantity supplied, it depends upon price. So that's why we always make sure we call it the inverse supply and inverse demand. We're just rearranging these equations to draw them on our diagram. So with vertical intercept of 2 and slope of positive 2, we have our supply curve. If you were using the vertical intercepts of 8 and negative 1, note your diagram would have been incorrect. So while these are perfectly fine for solving for equilibrium, you always must rearrange them and solve for inverse demand and inverse supply to plot them on your diagram. Now our equilibrium was, remember, 2 and 6. So we know equilibrium is the unique point where quantity supplied equals quantity demanded, and that was 2 in our case. And the unique equilibrium price at which this is possible is your $6 per unit. So that's our equilibrium in our market. Let's suppose the government institutes a price support program and it says that the price must be now $4 per unit. Let's see what will be the effect of this price support on our market. Quantity demanded is 8 minus P, but price is now 4. So quantity demanded is now 4 units. Quantity supplied is -1 plus half P, which is now $4. So that gives you half plus 2, which is 2 minus half would be 1.5 or 3/2. So you can see your quantity supplied and quantity demanded are no longer equal. In fact, quantity demanded exceeds quantity supplied. You can calculate the resulting shortage over here by taking the difference, and that will give you the exact amount of the shortage. We can represent this situation on our diagram. Again, remember we have our inverse demand and inverse supply that we've already solved for before. They were giving us this equilibrium point over here, and our equilibrium price was $6. Your price support program is lowering the price to $4. So you can see this will easily, visually at least, create a shortage. We have calculated the shortage by looking at this difference. So this difference will give you the exact amount of the shortage or the value of the shortage. On the diagram, at the price of 4, you can see quantity demanded is much higher than quantity supplied. Demand is the overall relationship, but quantity demanded is the specific amount that we're willing to buy at a specific price. So quantity demanded over here is much higher than our quantity supplied, which is 4 and 3/2 respectively. And the difference between these two will give you the exact value of the shortage created in this market because of this price support program. We can also represent changes in demand and supply given some linear equations. So in our case, these were our two initial demand supply curves with a vertical intercept of 8 and 2 respectively. Let's say this is my inverse demand curve and this is my inverse supply curve. So A over here is 8 and C over here is 2, right? So because this is 8 minus QD and this was, I think, 2 plus 2QS. So these are two vertical intercepts that we've already drawn. Note, whenever there is an increase in demand, it shifts the curve to the right. For a linear demand curve, assuming the rate of change is not changing, the slope is not changing, it will mean that your vertical intercept is higher. So with a higher vertical intercept, you know there is an increase in demand. Likewise, increase in supply is when the supply curve shifts to the right. So assuming again the slope does not change, it remains 2. A lower intercept is actually indicating a higher or increase in supply. Likewise, you can do the opposite. If assuming the rate of change is not changing, slope is not changing, we can lower the demand curve, and you will note that decrease in demand will be reflected by a lower vertical intercept, and a decrease in supply would be when the supply curve shifts inwards or to the left, and that is indicating a higher vertical intercept. So when you're reading these equations and I give you a new equation, instead of 8 minus QD, it changes to 6 minus QD. That is indicating a lower vertical intercept, so it's a decrease in demand. If your vertical intercept is higher, 10 minus QD, you have a new equation. This is indicating an increase in demand. Higher vertical intercept for your supply curve. So instead of 2, we have, let's say, 4 plus 2 QS. So you're demanding a higher price for any given quantity. So this is actually a decrease in supply. Supply curve has shifted to the left. And a lower vertical intercept, 1 plus 2 QS, is indicating a lower vertical intercept over here. So you are actually accepting a lower price for the same quantity, or you're saying supply has increased. So just some variations in your linear equations for demand and supply, indicating whether it will be an increase in demand or decrease in demand. So we have established the fact that we need to rearrange our equations in the inverse demand and inverse supply format to draw this on the diagram. However, does it matter which set of equations are we using if you're simply solving for equilibrium, or solving for quantity supplied, quantity demanded at a given price, or when we are solving for shortages or surpluses? In fact, we'll see over here that it does not matter which set of equations you use. Whether using your equation 1 and 2 over here, or you're using these two equations which are in the inverse format, your answer would be exactly the same. So let's quickly solve for equilibrium using our inverse demand and inverse supply curve and check, do we get the same answer as we got for these two equations over here? And just as a quick reminder, here we solved for equilibrium and our equilibrium price was $6 and our equilibrium quantity was 2 units. Now for equilibrium, remember we have a unique price at which quantity demanded equals quantity supplied, and that unique price is P star. So whether you're on the demand curve or the supply curve, price is the same. So using that concept again, we can now equate these two prices. 8 minus QD equals 2 plus 2 QS, and note quantity demanded is equal to quantity supplied at equilibrium. Hence I can get rid of these subscripts and simply call this my equilibrium quantity. So solving for Q star, we have Q star equaling 2. Substitute this quantity into any of these two equations because we were working with this set now. So let's put it in my demand curve or the inverse demand curve. 8 minus 2 is 6. So my price and equilibrium quantity are exactly the same regardless of which set of equations we use. For solving for equilibrium, for the math part, it does not matter whether you're working with your general demand supply curve or in their inverse format. It's only for the drawing part that we need the inverse demand and inverse supply curve to get our correct intercepts and our slopes.